Hello friends, I am Dr. Megha Bhamre, working as Assistant Professor in Kevin Naik College, Nashik. Here we will see the topic linear combination and spanning. What is meant by linear combination? Given a set of vectors v1, v2 up to vr be vectors in a vector space V. A vector u from vector space V is a linear combination of vectors v1, v2 up to vr if u is equal to k1 v1 plus k2 v2 plus k3 v3 up to kr vr, where k1, k2 up to kr are scalars. Now we see the example. Let v1 is equal to 1, 2, 3 and v2 is equal to 1, 0, 2 be vectors in R3. Express u is equal to -1, 2, -1 as a linear combination of v1 and v2. If u is a linear combination of v1 and v2, then we can write u is equal to k1 v1 plus k2 v2 and substitute the value of u, v1 and v2 in the equation. We will get -1, 2, -1 is equal to k1 into 1, 2, 3 plus k2 into 1, 0, 2. By simplification, we will get the equations as k1 plus k2 is equal to -1, 2k1 plus 0k2 is equal to 2 and 3k1 plus 2k2 is equal to -1. And if we simplify these equations, then we will get the values of k1 and k2 as k1 is equal to 1 and k2 is equal to minus of 2. And therefore, we can write u is equal to 1 into v1 plus -2 into v2. That is, u is a linear combination of vectors v1 and v2. Now we see another example. Let v1 is equal to 1, 2, v2 is equal to 0, 1 and v3 is equal to 1, 1 be vectors in R square and u is equal to 1, 0. Express u as a linear combination of v1, v2 and v3. If u is a linear combination of vectors v1, v2 and v3, then we can write u is equal to k1 v1 plus k2 v2 plus k3 v3 and the value of u is equal to 1, 0 means 1, 0 is equal to k1 into 1, 2 plus k2 into 0, 1 plus k3 into 1, 1. After simplification, we will get the equations as k1 plus k3 is equal to 1 and 2k1 plus k2 plus k3 is equal to 0. In this case, we get number of equations are 2 and number of unknowns are 3. Let us assume k3 is equal to t, where t belongs to R. Means k1 is equal to 1 minus t and k2 is equal to 2 minus t by substituting the values of k3 in above equations. Here, system has infinite number of solutions. If we take t is equal to 3, then we will get k1 is equal to minus of 2, k2 is equal to minus 1 and k3 is equal to 3. Means u is a linear combination of vectors v1, v2 and v3. Now we see the next example. Let a is equal to 0, 1, 2, b is equal to 1, 1 minus 3 be vectors in R3. Show that v is equal to 1, 3, 4 is not a linear combination of vectors a and b. If suppose v is a linear combination of vectors a and b, then we can write v is equal to k1a plus k2b. Substitute the values of v, a and b in the equation. We will get 1, 3, 4 is equal to k1 into 0, 1, 2 plus k2 into 1, 1 minus 3. By simplification, we will get k2 is equal to 1, k1 plus k2 is equal to 3 and 2k1 minus of 3k2 is equal to 4. From above equations 1 and 2, we get the values k1 is equal to 2 and k2 is equal to 1. If we substitute the value of k1 and k2 in LHS of 3, then we will get 2 into 2 minus of 3 into 1 is equal to 1, but which is not equal to RHS of equation 3. And hence we can say that u is not a linear combination of vectors a and b. Now let us study linear span. Given a set of vectors v1, v2 up to vr in a vector space V, the set of all vectors which are linear combination of v1, v2, vr is called the span of the set of vectors v1, v2, vr. That is, L of S is the set of elements of type k1, v1 plus k2, v2 up to kr, vr, where k1, k2, kr are scalars. Now we see the theorem. Let capital set S is equal to v1, v2, vr be the set of vectors in vector space V, then L of S is a subspace of V and L of S is the smallest subspace of V containing S. Now we see the example. Let U is equal to 1 to 0, V is equal to 3, 1, 1 and W is equal to 4, minus 7, 3. Show that W span set of vectors U and V. Let us consider W is equal to K1U plus K2V. Put the values of W, U and V in the equation. We will get 4 minus 7, 3 is equal to K1 into 1, 2, 0 plus K2 into 3, 1, 1. And after simplification, we will get K1 plus 3K2 is equal to 4, to K1 plus K2 is equal to minus 7 and K2 is equal to 3. Putting the value of K2 is equal to 3 in equation 1, we get K1 is equal to minus 5. For values of K1 and K2, equation 2 is satisfied. And therefore we can say that W is equal to minus 5U plus 3V spans V. Next example, show that the vectors V1 is equal to x plus 2 and V2 is equal to x square plus 1 and S is equal to set of elements V1, V2 do not span P2. P2 is a polynomial function of degree 2. Let V be the element of P2, then V can be written in the form of ax square plus bx plus c. If V is a linear combination of vectors v1 and v2, then V can be written as k1 v1 plus k2 v2. Substitute the value of v1 v2 in the equation. We get ax square plus bx plus c is equal to k1 into x plus 2 plus k2 into x square plus 1. After simplification, we will get ax square plus bx plus c is equal to k2x square plus k1x plus c1 plus c2. Comparing coefficients of constant x and x square on both sides, we will get a is equal to k2, b is equal to k1 and c is equal to k1 plus k2. Notice that if a is equal to 2, b is equal to 2 and c is equal to 2, there is no solution to these equations and hence S does not span V. Thank you.